In this video, we're going to take a look at the concentration of solutions, the molarity of solutions, and how to do dilutions with those solutions. So we use molarity because we could describe these solutions as we have in the past as either being saturated, unsaturated, supersaturated. That kind of just gives us a look at that solution if more could go in, or if it's completely filled, or if it's above its saturation. But as far as what is going on in that solution, since every solution has different amounts of solute that can be held in for a given amount of solvent, and then under different conditions of temperature, it doesn't really give us an idea of just how much is in there. So we use molarity, which is a measurement of the concentration. How much solute is dissolved per given quantity of solvent. And in looking at these solutions, we can describe them as being dilute, which means there's very little solute for the amount of solvent that is there in that solution, or concentrated, meaning there's a lot of solute for the amount of solvent in that solution. And we express this quantity when we measure it out as, again, molarity. We use capital M for molarity. Molarity is found by taking the number of moles of solute divided by the volume of the solution in liters. So capital M molarity equals moles of solute divided by liters of solution. So let's take a look at what these typical problems would look like. So when you get sick, you go to the doctors. Often the patient is given an IV saline solution, intravenous saline solution. And a typical one would have 0.90 grams of sodium chloride dissolved into 100 milliliters of solution. What is the molarity of this solution? So let's list out what we know and what we don't know and try and figure out where we need to head with this problem. Well, I know I have 0.90 grams of sodium chloride, and I know I have 100 milliliters of solution, and I'm trying to solve for molarity. And the equation I have for molarity is moles of solute divided by volume of solution, and I have neither of those right now. So we have to do a little bit of work in converting these into better units for us. So we take our 0.90 grams of sodium chloride, we're going to put it over 1, and we're going to convert these into moles because that's my solute, and I need my solute in moles. So I'm going to get the molar mass of sodium chloride, 58.5 grams of sodium chloride per every mole. There's my conversion factor. I need grams on the bottom so they reduce out. And I find there to be 0.015 moles of sodium chloride in that 0.90 grams of sodium chloride. For volume of solution, again, I need liters, but I have milliliters, so I take my 100 milliliters of solution, put it over 1, and I'll use my conversion factor of milliliters to liters, 1,000 milliliters in every liter, milliliters in the denominator, so they reduce out, and I find there to be 0.01 liters of solution. So now I have the units I need. I can now substitute those into my equation, and my equation is already solved for molarity, so I don't have to do any manipulation of my equation. So I take that 0.015 moles of sodium chloride divided by the 0.1 liters of solution, and I find there to be a concentration of 0.15 molar solution, or a 0.15 molarity. Oftentimes solutions are made from other solutions with a greater concentration by making a dilution. So when you make a dilution, what you're doing is just adding more solvent but keeping the same amount of solute. So I have less solute particles per solvent, but I'm not changing the amount of solute particles that actually were dissolved. So all it's really changing is the volume of my solution, making a greater volume, therefore giving it a lower molarity. So since the number of solute particles remains constant, we don't really need to worry about those. We're just going to take a look at how the volume and the molarity relate. And I see that there is a inverse proportion. So therefore, we're going to multiply these two variables. So as volume goes up, again, molarity goes down if the number of moles is held constant. So our equation for making dilutions is M1V1 equals M2V2. Again, where the molarity and the volume are going to be inversely related. So oftentimes we do see, again, where you're going to get a greater concentration, a very concentrated solution, and you dilute it down to the concentration that you need. You see that with like antifreeze. You can buy antifreeze in a concentrated solution, and then you can dilute it down and put it into your car rather than have to buy already pre-mixed and pay extra for water, basically. So let's take a look at one of these problems, and we got here a 2 molar magnesium sulfate solution, and I want to dilute it down to 0.4 molar solution, and I want 100 milliliters of it. So how many milliliters of that solution, my original stock solution, do I need? So let's figure out what we know and what we don't know. Again, we don't know how many milliliters of that solution we need, but we do know it's 2 molar to start. And then when we're done, we want a 0.4 molar solution and 100 milliliters of it. So I'm going to use my dilution equation, and since we're both in milliliters, we can just leave it in milliliters. We don't have to change those to a volume because it'd be the same conversion. So we can just keep it in milliliters and then solve in milliliters. But our original equation is M1V1 equals M2V2. And I'm solving again for that original volume of my stock solution I want to start with. So I'm going to manipulate this equation so it says V1 equals. So I got to divide both sides by M1. So I found my new equation to be V1 equals M2 V2 divided by M1. And now I can substitute into my equation my variables. So take my 0.4 molar solution times the 100 milliliters of solution that I want, divided by the 2 molar solution that I started with, and I find that I need 20 milliliters of my original solution to then solve for how much of my 100 milliliter 0.4 molar solution that we need. So I would take 20 milliliters of that original stock 2 molar solution. I then would add in 80 milliliters of water to dilute it down, and that would then leave me with again with that 100 milliliters of my 0.4 molar magnesium sulfate solution. And a good check for when you do these problems is your initial conditions, M1 and V1, you're going to start with a greater molarity and a lower volume, and then your final conditions, your M2 and your V2, you're going to have a lesser concentration with a greater volume. So since V1 is less than that 100 milliliters, that 20 milliliters is less than 100 we started with, then this is a good possible answer.